Page 763. We have two learning targets. We're going to find perimeters and areas of parallelograms. We're going to find perimeters and areas of triangles. The perimeter of any polygon is simply the sum of the lengths of the sides. So you find the length of every side, you add them up. Okay? Now, areas. An area of a figure is always going to be measured in square units, because technically speaking, it's how many squares of whatever unit you're measuring with would fit in the interior of the figure. Okay? And when you were younger, you may have actually drawn a figure on a piece of graph paper or had it drawn for you on a piece of graph paper, and you counted the little squares on the inside, right? Same idea. All right, that's what area is. It's the number of square units that fit inside. Now, we know, so we're going to start with parallelograms here today. So we know what a parallelogram is. It's a quadrilateral with both pairs of opposite sides parallel. Any side of a parallelogram can be called the base of the parallelogram. But the height, unless it's a rectangle, the height will not be one of the sides. The height is the perpendicular distance between any two parallel bases. And for all the figures we're going to talk about, whenever we use the word height, the height is the length of an altitude. An altitude is always perpendicular to a base. Okay? So, the height of a parallelogram is not necessarily a side. In fact, it's almost never a side. The only time it is when the parallelogram is also a rectangle. It's the perpendicular distance between the bases. Now, to get started on developing our formulas, we need to have this postulate. The area of a region is the sum of the areas of its non-overlapping parts. That's the reason back in the day you could count the little squares, because the little squares didn't overlap, did they? And so you just found each square unit had an area of one square unit. Okay? So you counted them, you added them together. So you were using that postulate even though you'd never heard of the word postulate at that point. All right, so to find the area of a parallelogram, as you probably learned previously, it's base times height, just like a rectangle. Oh, just like a rectangle. If I've got that rectangle, here's the base down here, here's the height, okay? The height is one of the sides right now, isn't it? But if I cut that triangle off and move it down here, I don't have a rectangle anymore. I have a parallelogram. But doesn't this parallelogram have the exact same area that the original rectangle did? So it has the same formula, base times height. The base is still one of the sides. The height's not. The height is this perpendicular distance between the two bases, because we can call that the base up here as well. Okay? You only need to call one of them base, but either one could be the base. All right? So, back to this. The area of a parallelogram is the product of a base B and its corresponding height H. So, the base and the height must be perpendicular to each other. The base can be any of the sides. But once you've decided what the base is, the height must be perpendicular to it. Okay? All right, let's try a few. Over on page 767, we'll start with number 1. It says find the perimeter and area of each parallelogram or triangle, round to the nearest tenth if necessary. So we'll try to round to where they tell us to round, nearest tenth in this case. All right, for number 1, getting the perimeter is pretty straightforward on this one. Okay, it's a parallelogram, so if that left side is 13 inches, so is the right side. And if the top is 15 inches, so is the bottom. So if we add 13, 13, 15, and 15, what do we get? So the perimeter is 56 inches. Let's try to always remember to put our units on the answer, because now we're going to have different kinds of units. Perimeter is just a linear measure, just like we've been using all year. So it'll be in inches or centimeters or miles or whatever. But when we find the area, it'll be in square units. And I'll show you how come here in just a minute. All right, so to find the area, we know that the area of a parallelogram is base times height. The base can be 15 because see how they show us that that's perpendicular? And I know that that length is 15 because it's labeled 15 up here, right? And we know that in a parallelogram, opposite sides are congruent. So the base is 15. I don't know the height. It's not 13 because that length of 13 is not perpendicular to the base. So I've got to find the height. And how am I going to find the height? Pythagorean theorem. So one leg squared plus the other leg squared equals the hypotenuse squared. So it's 25 plus h squared equals 169. So h squared equals 144. And what does h equal? 12 when you take the square root. So what do I put in for h in my formula? 12. Okay, get out your calculator if you need to, and tell me what 15 times 12 equals. 180. Now, the units. Since these lengths are measured in inches, our area is square inches, or inches squared. Here's why. I didn't write it down with the 15, but wasn't that 15 inches? And I didn't write it down with the 12, but that was 12 inches. So we multiplied 15 times 12 and got the 180. Well, then multiply inch times inch to get the inch squared. Okay? Now, I'm not going to make you write the units there, but you have to on your answer. Okay? Now, your science teachers are going to want you to write the units every step of the way. So if you're in that habit, then stay in that habit. All right? But I'm going to require you to have the correct unit on your answer. All right. Any questions on number one? Okay. Number two. Go ahead. Find the perimeter. And what is the perimeter? 76 feet. To find the area, it's base times height. What's the base? 18. What's the height? 16. How come everybody chose 18 for the base and nobody chose 20? Because the 16 feet is perpendicular to the 18 feet. Could 20 be the base? Yeah, but not if we are going to use the information they've given us. We'd have to then draw in a new height that was perpendicular to the 20, figure it out. And all. So you chose wisely, okay? If possible, choose a base that already has a height drawn in perpendicular to it. So you did, and what's 18 times 16? 288. So 288 square feet. All right, so far so good? Well, let's see what else we can do with this. Number three. We still need to find the perimeter and the area. Okay, so let's see. Perimeter, I think we've got all the information we need, don't we? Wouldn't that be 20 plus 20 plus 12 plus 12? And what do we get? So the perimeter is 64 centimeters. For the area equals base times height. What are you going to choose for the base, the 12 or the 20? Yeah, I'm choosing 12 as well, but I don't know the length of the height. Okay, or I don't know the height. Okay, it's not 20. This. Okay, now. Okay, a while ago I used the Pythagorean theorem, so maybe that's what I need to do. But then notice that 12 centimeters, that's that whole bottom side of that parallelogram. It's not just what I've outlined in red there for the triangle. Do I know how much of the 12 centimeters is outlined in red there? I don't. But what kind of a triangle did I just outline in red? 30, 60, 90. Okay? There's the 30. So I'm going to ignore that. That's going to mess me up if I keep looking at it. All right, if the hypotenuse of the 30, 60, 90 is 20, what's the length of the short leg? 10. And if the length of the short leg is 10, what's the length of the long leg? So the height is 10 times the square root of 3. So 10 times the square root of 3. Everybody follow me on that? All of a sudden you're starting to think maybe these problems are going to be a tad more difficult than you thought at first? Yeah, because see, they're not just going to give you the base and the height every time, are they? They're going to make you work for it. Okay? So I know that 12 times 10 is 120. So the exact area would be 120 times the square root of 3 square centimeters. The directions tell us to round to the nearest tenth if necessary. Well, it's necessary this time. So 120 times the square root of 3. Now, they did say nearest tenth, so 207.8 square centimeters. All right, we good with that one? All right, let's tackle number 4. All right, number 4. Can you tell me the perimeter? Not yet, right? Not yet. Because I know that 2 of the sides are 23 meters, the top and the bottom. I don't know what the left and the right are because, well, they don't give them to me. So the perimeter, it'll be 23 plus 23 plus. Okay, so what is it? Well, let's work this out. They've given us, well, let me start that over. Quite often, they will draw in the height in a useful place. If they don't, we will. For instance, if they'd drawn the height in right there, that's not a very useful place, is it? Okay? We need right triangles. Almost always, if they don't just flat out tell us the height, we need a right triangle to help us figure out the height. And in this case, not just the height, but also one of the missing sides of the parallelogram. Okay? So they put that in a good place for us because what kind of a right triangle do we have there? Yeah, we got a 45, 45, 90. All right. So if one leg of the 45, 45, 90 is 5, what's the other leg? Also 5. So now we know the height. We can get the area now. Okay? But we still can't get the perimeter because we don't know what the hypotenuse of that 45, 45, 90 is. If the leg is 5, what's the hypotenuse? 5 times the square root of 2. So, add in 5 times the square root of 2 twice, And now we can get the perimeter. So let's finish up the perimeter, then we'll go to the area. You with me on getting the 5 square root of 2? And are you with me that if it's 5 square root of 2 on the right, that it's got to be 5 square root of 2 on the left? Okay. So I know that 23 plus 23 is 46. If you had 5x plus 5x, you'd call it 10x, right? So if you have 5 square root of 2 times plus 5 square root of 2, that'll be 10 square root of 2. That's measured in meters. So that's our exact answer. They tell us to round it to the nearest tenth. So 46 plus 10 times the square root of 2. And I get 60.1. Is that what you guys get? So 60.1 meters when I round it to the nearest tenth. Okay? Now let's get the area. Area equals base times height. So choose 23 as the base, and it's labeled, the 23 is labeled on the top, but that could also be the length of the bottom side of the parallelogram, right? So the base has a length of 23 meters. And then we discovered when we were working with our little 45, 45, 90 triangle that the height is 5. So what's 23 times 5? So we get 115. Let's try that again. So we get 115 square meters. All right? We're good with parallelograms? So, if they give you all the sides and they give you the base and the height, then there's really not much easier in math than area and perimeter. They're not going to give you all that information. You're going to have to use the Pythagorean theorem, 30, 60, 90, 45, 45, 90, trigonometry, to find lengths that you need. Okay? All right, triangles. Like the base of a parallelogram, the base of a triangle can be any side. The height of a triangle is the length of an altitude drawn to a given base. The height is the length of an altitude. An altitude starts at a vertex and is perpendicular to the base. So like we just found out with parallelograms, sometimes you have to choose wisely. Choose as your base a side that you can draw an altitude to and get its length. Okay? So, identifying the base and the height, we'll have to get pretty good at that. Now let's take a look at this postulate. If two figures are congruent, then they have the same area. Well, it's a good thing that's a postulate, because didn't you just kind of assume that already? If they're the exact same size and shape, then they will enclose the exact same amount of area. All right? Now, we're going to use that fact right here. Right here, I have a parallelogram whose area is base times height. And I've drawn in a diagonal. When I draw in that diagonal, since that's congruent to that, and that's congruent to that because it's a parallelogram, and that's congruent to itself, aren't those two triangles congruent by side, side, side? So they both enclose the same amount of area. Wouldn't the area of each one be half the total area of the parallelogram? So if I take one of these triangles and get rid of it, the area of what's left is half the original area of the parallelogram. And that's where the formula comes from for the area of a triangle. Make sense? Okay. So here's the way the book says it. All right, it says the area A of a triangle is 1/2 the product of a base B and its corresponding height H. In symbols, I prefer this. There's nothing wrong with the other one other than I won't use it. If you want to, you can. Okay? Base times height divided by 2 is the same thing as 1/2 base times height. So 1/2 base times height is the way I want you to say it. If you find it more convenient to use base times height and then divide it by 2, that's what I do in practice a lot of times. I just never write it that way. Okay? So, back to our assignment. Number 5. We're still finding perimeter and area. Now we're doing it for triangles. On number 5, to get the perimeter, well, I know 2 out of the 3 sides. So the perimeter is going to be 5 inches plus 21.5 inches plus whatever the length of that missing side is. And I don't know the length of that missing side, but have they given me enough information to find it? Yes. And how are we going to find it? Pythagorean theorem. So 8 squared plus 15 squared equals that missing side squared. So that's 64. What's 15 squared? Plus 225 equals c squared. And what's 64 plus 225? 289 equals c squared. Is 289 a perfect square? Yeah, what's its square root? So 17 is the length of that missing side. So to get the perimeter, plus 17. And what is 5 plus 21.5 plus 17? 43.5 inches. Okay? All right, now, let's get the area. The area of a rectangle. Area of a triangle equals 1/2 base times height. So that'll be 1/2. Now, let me get rid of that. Don't need that anymore. Our base and our height. Let me get rid of that too. See how this segment right here, watch me now, is perpendicular to this side right here, but it doesn't intersect that side. Yeah, I know. I didn't really say it correctly, did I? What I should say is the segment with a length of 8 inches is perpendicular to the line that contains the side that's 5 inches. But here's what I need you to understand. The 15 inches, that's not the base. 5 inches is. The base must be the length of a side. Triangles are weird. Obtuse triangles, the altitude is outside of the triangle. In acute triangles, the altitude's inside the triangle. In a right triangle, one of the legs can be the altitude. But in an obtuse triangle, the altitude can be outside of the triangle. Okay? So the 8, that's the length of the altitude. That's the height. The 5, that if you extend the lines, it's perpendicular to, that's the base. The 15 has nothing to do with the base. The only reason they told us that 15 was so that we could figure out the missing length to get the perimeter. That's the only reason they told us that. Okay? Now, this is important because you'll miss it on the quiz if you're not careful. The 15 is not the length of the base. You with me? The base is always one of the sides. Always, always, always. I don't care what kind of figure you're talking about. So that couldn't have been the length of the base. It must be the 5. Okay? So the base is 5. The height is 8. Now, you can multiply in any order you want. So here's the way I do it in my head. What's half times 8? 4. What's 5 times 4? So 20 square inches is our area. All right. Number 5 makes sense. Number 6. Okay, let's get that perimeter. Well, they only give me the length of one side. 30 millimeters is the only side length they give me. So I'll start there. 30 plus. Okay, it's going to take me 2 steps to get this, or two different it'll take me a while. First, I'm going to use this triangle to find that missing length right there. And I'll use the Pythagorean theorem on it. Okay, so 12 squared plus a squared equals 20 squared. That'll be 144 plus a squared equals 400. What's 400 minus 144? And then what's the square root of 256? All right, so I've got that side. So now I know that one's 16. So plus 16 plus, and I'm still missing one more side before I can get the perimeter. Well, I need to use the Pythagorean theorem again on the actual triangle, don't I? Okay? Because if that's a right angle, so is that. So I've got a right triangle. So 16 squared plus 30 squared equals the hypotenuse squared. All right, 16 squared is 256. 30 squared is 900. So that's what, 1156 when I add those together. Is that one a perfect square? Now, what's its square root? What is it? 34. That's what I was missing. Get the perimeter, isn't it? So 30 plus 16 plus 34. 80 millimeters is our perimeter. You never knew perimeter could take that long to figure out, did you? They're just simply not going to give you all the information you need. And there's no need to, because if you're given all the information, you could have done these problems 4 years ago. So they're not going to give you problems you could have done 4 years ago. Okay? All right, let me get rid of all this. And now, let's go to work on the area. Area equals 1/2 base times height. So 1/2. Now, since this is a right triangle, one of the legs can be the base, the other leg can be the height. So I'll use the 30 millimeters as the base, use the 16 millimeters as the height. I know that 1/2 times 16 is 8. What's 8 times 30? Yeah, it's got to be 240. And what's the unit on our answer? Millimeters squared. All right. We still doing okay? Number 7. Marquez and Victoria are making pinwheels. Each pinwheel is composed of 4 triangles with the dimensions shown. Find the perimeter and area of one triangle. Okay. Perimeter. Ooh. Perimeter should be easy, right? They give us everything we need. Isn't it 9 plus 11 plus 8.5? So what's the perimeter? 28.5 inches. To get the area, I know the formula is area equals 1/2 base times height. What's the length of the base? Yeah, let's go with the 9. The reason I chose the 9 is because there's already a segment drawn in for us that's perpendicular to it. Okay? So that's the base. Now I got to figure out the height, don't I? Okay? So let's call that H for height. And how am I going to get the height? Can I use that? Blue was a bad color. Can I use this triangle right here to find the height? Yep, that's what I need to do. So 4 squared plus h squared equals 8.5 squared. So it would be 16 plus h squared equals, and I'm going to need my calculator for this. 8. Yeah, question? Huh? Yeah, that's an oversight on their part, isn't it? Yeah, y'all see what he's talking about? They've actually given us lengths that can't work out. Because if you went with this whole big triangle, if you took that big triangle I just outlined in red, the hypotenuse of it is 11, but this side of it would be 13. So they've actually given us a figure that cannot actually exist. But we can play along. So that'd be 72.25. Then we subtract 16 from both sides. Not like that, we don't. Get rid of that. Try that again. Minus 16. So that'll be h squared equals 56.25. And I wonder what the square root of that is. So we do the square root of our last answer. Oh, that's nice. 7.5. No rounding required. All right, so 1/2 times 9 times 7.5. Well, I know that 1/2 times 9 is 4.5. So if I take the 7.5 I've already got times 4.5, so my exact answer is 33.75 square inches. And I really hate to round this one. Did they tell us to round? So I'm not going to. I mean, when I've got a nice exact answer like that and they don't tell me to round it to some other place, I'm going to stick with this. All right. Still hanging in there with me? All right, number 8. Now, these are more like ACT questions. Well, I take that back. Not more like. These are also like, because the other ones could be the ones where you have to do at least one, maybe 2 other things before you can find the area. That's the kind of things you see on standardized tests. Another thing you see is using a formula backwards. Instead of computing the area, they give you the area and ask you to compute one of the missing parts, the base or the height. Okay? And that's what they do here on number 8. We have a parallelogram. And I know that the area formula for a parallelogram is area equals base times height. Let's fill in everything we know and solve for what we don't know. So the area is 153 square inches, so replace the capital A with 153. Now if we look at the parallelogram, remember how the base will always be one of the sides and then the height has to be perpendicular to it? What needs to be the base? 9. And if the base is 9, what's the height? X. Well, that's kind of tailor-made once you write it down, isn't it? All right, so all I've got to do to find X is take 153 and divide it by 9. So 17 equals X. Now, I need to put the unit. I should have put inches. 17 inches equals X. And one more example. Number 9. This time, it's a triangle we're working with. I know that the area of a triangle is 1/2. Base times height. Let's fill in everything we know. Solve for what we don't know. So replace the A with 165. 1/2 stays 1/2. All right, now, what's the base? (41 minus 11). Because the base has to be the length of a side, okay? So let's let the base be the length of that blue side right there. The length of that blue side of the triangle is not 41, and it's not 11. It's 41 minus 11. So the length of the base is 30. And then they've got the height labeled for us. What do they have it labeled as? X. Because the height must be perpendicular to the base. And so this red segment right here is perpendicular to the blue base. So X is our height. Well, that'll be 165 equals 15x. And what's 165 divided by 15? 11. So that'll be 11 centimeters equals X. Questions? All right. On page 767, let's do 1 through 27, 30 through 34, and 42 through 45.